Hello, this is the Genuinely Approachable Sudoku for the 17th of January 2024. It is Mighty Crop by Philip Newman. So let's look at the rules. Normal Sudoku rules apply, so digits 1 to 9 in every row, every column, and every 3x3 box. Crop key pairs, digits in cells separated by a white dot, must be consecutive, so we have a difference of 1, meaning that it could be a 7 and 8. So it could be like that. It could be 3 and... well, it can't be 3 there, but you get it. These two are consecutive digits. Cell separated by a black dot must have a ratio 2:1, which means that one digit is double the other. You could have 8, 4, 2, because 8 is double 4 and 4 is double 2, and so on and so forth. No negative constraint. That means that it is possible for digits without dots between them to fulfill one of the rules. So yeah, so it's possible for these two to be consecutive, for example, or these two could be, they could be in a ratio 2:1. That's fine. Alright, with that, let us begin solving. I see the 4 in the center followed by 8 different digits outside, which is fairly interesting, I guess. But these long strips of 2:1 are very interesting because along these black dots, we only have a few possible options, and they are 1 2, 2 4, 4 8, and 3 6. Those are the only possible pairs you can have, and the only pair that consists of 4 different digits in a row is the 1 2 4 8 quadruple. And so it's 1 2 4 8 in either direction, but because this can't be an 8, you can't have a 1 2 4 8 going downwards, and therefore must be a 1 2 4 8 going upwards. Now this one is also 1 2 4 8, but can't be one going downwards from here, so it must be another 1 2 4 8 going upwards as well. The remaining digits in the remaining digits in this column, 3 5 and 3 7 and 9. 3 7 9. And in here we have 5 6 and 9. We can remove 9 from that cell. Alright, we can also remove 9 from this cell, and the reason why is because these 4 are 4 consecutive digits, and they must all be different because they're in the same row, which means that, well, it can't be 9 because then that will have to be beside 8, which breaks. But more importantly, if this is a 3, it must increase 3 4 5 6. If it's 7, it can't increase to 8, so it must decrease 6 5 4. So if it's 3, it's 4 5 6. If it's 7, it's 6 5 4, which means this must be a 4 5 6 triple, with the center digit always being 5. Yes, okay. So these digits are now 3 7 9. Okay. Well, this 5 and this 6 might be also interesting, because if it's 5, it can't go upwards, because it will go 5 6 7 8, which would then clash with that. So it must go downwards to 5 4 3 2, which also breaks because 2 is in the box. So in fact it can't be 5, because we know 5 cannot go upwards or downwards. So this must be 6, which must go downwards because going upwards will hit 8. So it must go 6 5 4 3. That can't be 3. This can't be 6. This 3 7 9 triple here makes this a 5. Therefore that is a 9. This digit must now be a 2 to complete the box, and that must be a 7 to complete the row. Here we have 3 8 3 8 2 3 8 2 3 8. That is not 3. Okay. Now here maybe, or maybe here. Yeah, because the 3 cell long cannot also be 3 6 either, because 3 6 can only exist as its own contained pair. So this strip here must also be from 1 to 4 8 as well, as must this. This can't be 8. So if this is a 2, this would have to increase to 4. Yeah, so this can't be 2, this can't be 4, this can't be 8. But I think it can be in any other order we want. So it could be 2 4 8. also and so. But that does actually mean something, because this now can't be 1, 2, 4, 8. Because these must contain this must contain 3 digits from 1 to 4, 8. But if we had this be from 1 to 4, 8, that would contain a total of 5 digits from 1 to 4, 8, which cannot exist because there are only 4 digits in 1 to 4, 8. So this must be 3, 6. And same here, this must be 3, 6. This 3 sees that, so that's 6, that's 3. 3 must appear in, okay, yeah, in this box, these 3s look at, they look at these cells. So this must be a 3. This can't be a 4 because of the 4 and a 4 up here also does that. So it must be 2 going down to 1. This now cannot be 2 or 1, and therefore must be 8. So this must be a 2 which goes up to 8, like so. This now can't be 2 or 8 and is 3. Okay. Here we have 5, 6, 8 to complete the box. That can't be 6, that can't be 8. And here is 5, 6, 9. And here can't be 5 or 6. So this is 9. This can't be 6, so that's 5. And so this is 6. That is, well, that's no longer 6. Okay. These digits are 1 and 7. 1 sees that. So that's 7. That's 1. Still nothing there yet. Okay. 1, 2, 3, and 4 are all out here. Should we have 5, 6, 7, and 8? That's okay. I think we look at this now. This can't be, well, if it was above 6, it must be 7, 8, 9. But that doesn't work because 7 and 9 in this row, in this column, means that this can't be 7, 8, 9 or 9, 8, 7. So it in fact can't be above 6. It can't be 2 or less either. So it must be between 2 and 6. So it must be 3, 4, 5. This 3 here means that is not 3. That has to be 5 then, because 4 is in the middle. And 4 is in the middle because, it's either 3, 4, 5 in either direction. This now can't be 4. So this can't be the 2, 1 thing. So this is 1, 8. Wait, what? This can't be 4. No, this could still be 2. This can't be 8. Yes, it can't be 8. I don't know what my brain is on right now. But I think this is all still okay. Right. What now? I don't know. This is 1, 7, 8, 9. 1 can be, well, 1 could be there. 1 in this box. Yeah, there's a. Is there a 1 in one of these cells? Because it can't be 2, 4, 8. Because 4 will be then put in the middle, which breaks. So it must have a 1 somewhere, and 1 can't be in the middle either. So that can't be 1. That's 2, which means it has to be 1, 2, 4 like that, right? I think that's forced. So 1 goes in that cell. Here we have 6, 7, 9. Which works. Okay. Here we have 5, 7, 9. Yep. And I think that is a chocolate teapot because that can be 5. That can't be 9. That can't be 7. Now this is 5 or 7, which means this must be 6 or 8, I think. Because it has to be adjacent to this digit. Okay, here we have 7, 8, 9 to complete the row. I think it's something here that I'm just not focusing on. It's not though, because yeah. Here we have 2, 7, 8. Where this cannot be 2 and that cannot be 8. This is a 7, 8, which means this must be, well, if it's 8, it can't be 9. Yeah, if it's 8, it can't be 7 or 9. So this can't be 8. That's 7. That's 2. That's 8. That's 2. This 7 must be next to 6 or 8, and we don't know. And well, here we have a 4, 6, 8 triple, but 4, 8 over here means it has to be 6, which resolves that. That must be 3. Well, that must be 3. That must be 6. This must now be 8. So that is 4, 6, which means this must be a 7. So that's 9, that's 3, that is 9. These are not 9. 5, 8 patchy sees that. So that's also not 8. Which means that 8 in this row must just be there. This must now be 6, which could still be adjacent to either of these digits. But that's now a 7, that is now a 6. These digits must be 8 and 7, which means this is no longer 7, that's 5. This is 9, this is 8, that's 5. This 8 means that's 7, that's 8. And this would be 4. This must now be 7 because of the 9 in the column. This is 9. Here we have 5 and 9. Yes, this must now be 9. That's 5. Here is, I think, 1 and 7. 7 sees that, so that's 1. That's 7. This is now 3 to complete the box. Here we have, 1 goes there, and therefore the last digit here is a 9. Solving the puzzle. Well, just under 10 minutes, but I think that was pretty slow. With that, I hope you enjoyed this video. I will see you next time. Bye bye.